Hello, I am Renny and welcome to day 14 of Sudoku September. Today we're going for one of the suggestions from the authors on Sudoku, which is called Broken Thermometer. So we need to divide into 6 connected regions, which must continue digits up to 6 in every row, column, and region. Larger thermometer is broken into sections by region borders, and digits separated by d must add up to 5. So they are going to be 1, 2, 3, 4 in some order. So this is going to be okay. Okay, so let's think about how many different regional border crosses would it be? Well, we know actually, so the sum of everything is going to be 21 times 6, which is 126. So it's going to be, in terms of the amount of times it's going to be split, it's going to have to be divisible. If it was divisible by 6, which we could probably quickly figure out if it isn't. It'd have to be like something like that times the regions. And would we end up having any issues here actually? That would be the same as that. I mean, these are thermometers, aren't they? Actually, yeah, sorry, yeah. All of them do have the same sum, but actually, that's an interesting point. No matter what, this, if it was a 6, this would have to be a 1, but that makes that a 6, so it doesn't work. Now, the next reasonable factor of 1 to 6 that we could try is 9, I guess. No, probably not 9. No, in terms of here, we're split into 9 sections. Each section would have to add up to 14? That was no. Really? Yeah, I guess it is. Yeah, okay. So that would be. Actually, that's an interesting point because of, I guess, how thermometers work. We know there has to be more than 6 regions. We also know wherever there is a 6, there's going to be an immediate break. And wherever there's going to be a 1, there's going to be an immediate break just before. So I think that, does that mean, I don't know if that actually means that, well, that'd be one way of proving that 6 is a thing. That would be, I guess, a good test for if there are 9, we would need to have 3 regions which are sort of 6 and 1 back to back, I guess. Now, each one adding up to 14. The only way something could realistically add up to 14, right, are 2, 3, 4. They're just if they're leaving out 7, I guess, which could be done in a few ways actually. Actually, this is an interesting point, right? So this can't be a 1 because that would be isolated. That wouldn't work. So that's not a 4. Similar vein, this can't be a 2 because it would mean that all sections have to add up to 3, and that just doesn't work. So it can't be 2. So that's either 3 or 4. That's either 1 or 2. Okay. So this being either 3 or 4, just put some limits on here. This is either 1, 2, or 3. And it would be worth noting that it can't be 10 because 1, 2, 6 doesn't divide by 10. So this isn't going to be a 4. And so it's either going to be, but let's say, for example, if this was a 3, it has to be that for 6, because if it was 5, then there would be no way for a 6 to go anything. If it was 6, it means that every single 6 acts as a region break. But there's only... well, actually, we haven't necessarily figured out these are both in different regions. We know that one of those two is definitely going to be a region. We know that one, I think, for definite is going to be in. Now, if it was like that, it would have to be 1, 2, 3. I guess in theory it could work. We know that I guess 5 and 6 have to be somewhere in there. We don't know where they cross through. But yeah, our options are either it adds up to 6, or it's going to add up to 7, or it could add up to 9, or even 8 actually. But if it adds up to 7, whether this is specifically 4, 3, I guess actually I will colour them in different, just so I can sort of track the sections on a thermometer, and then I can colour them in that afterwards. That being a 7, what suffix would that have? I guess we would know how this is divided. It would have to be divided in groups of 2 along here, really. Actually, no, not so. Again, if it was 7, then if wherever there's a 6 has to be followed by a 1. Does that make a 1, 2, 4 possible? I don't think so. Like, so, take for example the 6 in this column. Say it's there. We've got a 1 here, and we'd have another 1, say that there, or not there, say another lot like there maybe, and then we'd have like another lot there, and another lot like there, and there, for example. Like, I'm not saying this is how the 1s and 6s are going to go. I mean, it wouldn't be like this anyway because it's the wrong direction. But the point I guess I would be making is that once you have gone through all the options for 6s, the other 7s, right, you can't have 2, 3, 4. Well, 2, 4 is 9. It's not like one could belong into another group of 3. So it would have to be that I think that is, if it is like 1, 6, that it would have to just basically, if it is 7s, we know that they are going to be all just doubles. With that in mind, we could probably prove that, like, if we just highlighted all the doubles on here, we could see if there is any viable combination. Oh, here. So this one, if we are going through doubles, as we've established that, like, there can't be any triples if they add up to 7. This one. So in terms of, it is possible for that to be a break. Never mind. It is possible, but I'll try and highlight that a bit more in terms of how, after we've done all this highlighting, this figuring stuff out. Actually, you know, I think I'm gonna redo how I'm coloring these actually. Green, that's gonna be blue, that's gonna be pink, red, orange, blue. Doing it in just sort of rainbow orders, so I know kind of what can match with what. Well, it's more so that I know that, like, primaries have to match with primaries essentially. And secondaries would have to match with secondaries. Well, not all the times, but like any of the ones otherwise it can't match up with. So for example, this one here would have to match up with this. I'm gonna do any of these large groups in some of these darker colours. So I'll call this one brown. That has to go with all those. That cannot go with those, and it cannot go with those. So it would have to go with those two. Now, this one can't go there, so I think it has to join with those two, and that cannot go down, so it would have to go with those two. Call it on the label. So this one cannot go with either of those two, so that's got to join with that, and that cannot join with either, you know, the green with the pink on that 45. So I think that is going to be one. Highlight that one in dark green. Okay, this one has to join with at least one of those. And it's more likely it's going to join with both of them. It's proven that this one cannot join with the blue, so it's got to join with that one. It cannot join with that yellow, so it would have to join with that one. Or it could join with the red, I guess. If it was blue, yellow, that. Okay, so we know that those two, they're going to be within one. We know that these two are going to share one. And we know that it is going to be this one. All we don't know is whether this one is in the blue or in this sort of like rust, and vice versa. Now the question is, does this layout work? No. Reminder, what we're saying is that's a 4, that's a 3, that's a 1, that's a 6. I guess we could just start by just trying stuff out. So that's got to be 2, 5. That has got to be 2, 5. That's 6, that's 1. 2, 5 would have to go in order. They've got to be 3, 4. Could be 2, 5, could be 1, 6. That can't be 1 or 6, that's got to be 2, 5. Which makes that one a 2, that's 5. And that one is going to be 3, 4. And that one is going to be 1, 6. That's going to be 1, 6, which will be going that way. Be 1, 6 going this way. Be 3, 4. It's going to be 1 and 6. This looks like it's going to work actually. That's going to be 2, 5. That's going to be 3, 4. Boom, there we are. Did not necessarily expect that to work, but yeah. That sort of trying to do proof of contradiction ended up working, I guess. But yeah, this was actually, I don't know. It did feel kind of trial-and-error, but I think I liked sort of the working out what the pattern is, and I guess if we do actually look pretty quickly. But yeah, like 1 and 6 was in always red and green. 2 and 5 were always in orange and blue, and 3 and 4 were always in yellow and magenta. So yeah, that was pretty fun. I'll probably do another of like the no 3 in a rows for tomorrow. But yeah, I'll see you then.